Forget acid rain or the strongest hurricanes recorded on Earth. Out in deep space, planetary conditions create weather systems that operate on a scale of intensity we are only just beginning to map. This is WASP-76b, a massive gas giant where the local forecast doesn't involve water, it involves a constant downpour of molten liquid iron. On our world, iron is the permanent solid foundation of our cities. But on WASP-76b, the ambient energy is so high that this heavy metal behaves with the fluidity of common water vapor. To understand how a planet can sustain a metal-based weather cycle, we have to track the specific physical journey of a storm across its surface. This environment forces us to look past our Earth-centric definitions of how a planet is supposed to function. Located 640 light-years away in the constellation Pisces, WASP-76b is what astronomers call a hot Jupiter, a gas giant that lives in an incredibly hostile orbital neighborhood. This orbital map shows the scale of the problem. While Mercury is the closest planet to our Sun, WASP-76b sits nearly 10 times closer to its own host star. At this proximity, the star's gravity has locked the planet's rotation. One side is permanently fixed toward the stellar fire, while the other faces the cold vacuum of space. This creates a permanent thermal duality, an eternally scorched day side, directly opposing a hemisphere of permanent, freezing darkness. This locked state acts like a massive thermal battery, providing the constant energy source required to drive the planet's atmospheric chaos. On the day side, the atmosphere is hit with thousands of times more radiation than we receive on Earth. This pushes local temperatures to 4,300 degrees Fahrenheit. That is hot enough to turn a standard industrial furnace into a freezer by comparison. Under this heat, any solid iron present doesn't just melt, it experiences a rapid change of state. The iron is pushed past its boiling point, completely dissolving into a thick, metallic iron vapor gas that rises into the upper atmosphere. In this system, the day side functions as a planetary-scale furnace, converting solid matter into the gaseous fuel that powers the coming storm. Because of the massive temperature difference between the two hemispheres, the atmosphere creates a powerful vacuum effect, pulling air from the hot side to the cold side. This creates high-altitude winds that carry the iron vapor toward the night side at a staggering 11 kilometers per second. As the gas crosses the terminator line, the boundary between day and night, it leaves the 4,000-degree heat and enters the much colder nighttime environment. The sudden drop in temperature causes the iron gas to condense. The vapor molecules clump together, turning back into heavy liquid droplets. Once the metal returns to a liquid state, its weight becomes too great for the wind to sustain. Gravity takes over, pulling the molten iron down through the dark atmosphere. This is the reality of WASP-76b, a world where heavy, glowing drops of liquid metal fall continuously through a sky of total darkness. If a space probe were to enter this region, it would be instantly pelted and destroyed by the sheer kinetic force of these molten drops. These discoveries show us that exoplanets are not just static rocks in the distance. They are dynamic thermodynamic machines driven by extreme orbital mechanics. The mechanical reality of our universe is often more intense and complex than the scenarios we imagine in science fiction. To keep exploring the most extreme environments in the known galaxy, hit subscribe and join us for the next journey.